All right, folks, so we're here to kind of review for our Unit 3 quiz that we're going to have. We started out this unit talking about, in section 3.2, slope, and we defined slope as the steepness of a line. You learned a three-word phrase that we thought was very important, rise over run, that will describe slope. And we also understood that m is the variable that we use to represent slope. We have four types of slopes. One that goes to the upper, up to the right, down to the right, horizontal, and vertical. Up to the right is a positive slope, down to the right is a negative. This is what we would call a zero slope, and this one here is undefined. Now, we looked at finding slope a multitude of ways. The first way, we just saw a line on a graph, and we try to calculate the rise and the run. So let me give you a couple of points. Let's go with -1, 3, and let's go to -3. All right, and we'll make a line through there. All right, so we need to get from point to point utilizing our idea of rise over run. Doesn't matter if I go from here down or from here up. It don't matter. We just need to count the boxes. So if I start from here, I'm going to go up one box, 2, 3, 4, 5, and 6. Since I went up, that's a positive 6. And then from here to here, I went 1, 2, 3. But since I went to the left, that's a negative number. So my rise is 6, my run is -3, and that should just simplify to 2 over -1. If I decided to go the other way, that's okay. Went down 1, 2, 3, 4, 5, and 6. Since I went down, that would be a -6, and then I went to the right 1, 2, 3, and that's positive. So it'd be -6 over +3, which still is just -2 over 1. And those two things are the exact same. There's no difference. Either one of those is correct. So it just kind of depends on your preference and what you see and what makes the most sense to you when you're finding the slope there. All right, but we just need to make sure that it is an improper fraction. Leave it improper. Make sure your fraction is simplified. No decimals within your fraction. We also learned a way to find slope, either using slope formula This is where we had y2 minus y1 over x2 minus x1. So if I were to give you a couple of points like, I don't know, 7, -2, and 4, -3, I would plug my information into this formula and solve. So -3 is my y2, my second y, so we're just going to have two fractions with subtraction signs on top. So I'm going to put -3 in this spot. y1 is here, that -2, so I'll put it there. 4 is my x2, 7 is my x1. And I'm just going to subtract from here. -3 minus -2 is just really -3 plus +2. That's going to be -1. 4 minus 7 is -3. We did learn that I'm not allowed to have two negatives, so a negative divided by a negative is a positive. So my slope for this would be 1/3, a rise of 1, a run of 3. Okay? Since it's positive, I know that this line would be going up and to the right. And that's pretty much everything that we saw within slope. We then talked about direct variation. If y equals 6 and x equals 4, we need to find x when y equals 32. All right, so this is where we said, okay, we're kind of creating a proportion. All right, we're finding the slope of the information over here, and we want it as y over x, which is just 3 over 2. I can put it into my y equals mx formula, meaning this is my m, so I plug it in. They say this is y, so I'll plug it in here. And then I can solve. 32 equals 3 over 2x. And to solve this equation that we have created, we just multiply by the reciprocal. on both sides. And when I do that, I get an ugly number a little bit, but that's okay. I can't simplify anything, so it just really becomes 64 over 3. And 64 over 3 is really, if I divide, I think that's 21.3 repeating equals x. All right, so that's one way we can do it. Or I said, hey, let's use the idea of proportions. Something over something equals something over something else. 6 is y, 4 is x, 32 is y. We don't know what x is. And we can cross multiply and solve, and I get 6x equals, looks like it's 128. If I divide by 6, I still am going to get that number. All right, so either way would work. It doesn't really matter to me. I just kind of have to set up, either create a slope or set up a proportion. Same type of idea, though. The last thing that we looked at is section 3.4, where we start working with slope-intercept form. And slope-intercept form is that formula, y equals mx plus b, where we have m as our slope and b as our y-intercept. All right, so if I give you an equation like y equals -1/2 x plus 4, I can graph this information using this formula. Well, first thing I see is my y-intercept here. It's an ordered pair, 0, 4. Then I see my slope, and I got a negative out in front, and I always like to put the negative with the numerator, just so I know where it's at. And then we give directions. This is the rise, and the rise is a negative, so that tells me we're gonna go down. This is the run, and it's positive, so I know we can go to the right. But if I wanted to, I could switch it the other way. If I put the negative sign the other way, like 1 over -2, that's fine. It just tells me that I'm gonna be going up and left, and that will work too. It's saying the exact same thing. So if I take my graph, we've been taught that, okay, we're gonna put a dot at our y-intercept first, over 0, up 4. I put a dot. Then I'm gonna follow my slope. Down 1, 2 right, I put a dot. Down 1, 2 right, I put a dot. I need at least 3 points. I got my 3. I wanna make a straight line through as much of the graph as I can with arrows at the end. And that's it. That's pretty much what we're gonna be assessed on for our quiz. Let me know if you got any questions. Peace.